So, now let us see Jurin's formula for the ascent or descent of liquid in a capillary. So, we have a capillary in a liquid, suppose this is the liquid vessel and we have a capillary here. So, this is the liquid and the liquid is rise is up to this height h. We wish to calculate h. So, first let us see this first method, that is our excess pressure method. So, this is the first method of our calculation of the capillary rise. So, what we do, this is 0.1, this is very close to this meniscus 0.2, but inside it, and this is on the free surface 0.3. So, we have selected 3 points, one in the air, two just inside the liquid meniscus and third on the surface. So, applying excess pressure formula at the meniscus. So, this assume that this is a spherical meniscus. So, for a spherical surface we have the pressure difference as 2s by r. So, we will write that P1 will be more than P2, this is excess pressure, by 2s by r, where r is the radius of curvature of the meniscus. R is the radius of curvature of the meniscus. Now, you see P1 is P naught minus, so this is equation number 1. Now, we have again pressure variation along the liquid column. So, from hydrostatic pressure distribution, pressure variation, we have P3 is equal to P2 plus H rho g, where P3 is again P naught because it is on the same level of this free surface, P2 plus H rho g, this is equation number 2. So, from 1 and 2 we get, if I P naught, if I put here, I will get P2 plus H rho g minus P2 is 2s by r, implies H rho g is 2s by r. Thus, H is equal to 2s by r rho g, where r is the radius of curvature of the meniscus. Now, let us relate the radius of curvature of meniscus with the radius of the capillary. So, this is the capillary and suppose this is the radius of curvature. So, if I draw the tangent here and here, you can see this angle is theta, angle of contact. So, this is 90 minus theta, so this is again theta. So, you see this is the radius of curvature of meniscus and this is the radius of the capillary. So, you have small r by capital R as cos theta. So, what we do, H is equal to 2s by rho g. I will write 1 by r as cos theta by small r. So, 2s cos theta by r rho g. So, this is nothing but Jurin's formula. So, Jurin's formula tells h, the height to which the meniscus will rise will be 2s cos theta by r rho g, where r is the radius of the capillary. This capillary is of circular cross section. Now, come to the second method, equilibrium of force. Second method, that is equilibrium of force. We say it is force method, force. Now, in equilibrium of force method, what we do, this is our capillary, and let us somewhat draw it. This is the liquid in the adjacent surface. So, here you see this liquid surface meniscus is like this with the height h. So, you see here this surface is pulling here with the force surface tension. So, you will have a force acting along this direction throughout this. So, you can see, just imagine the force here. So, throughout this curve you can imagine this is whole meniscus. So, this force is the surface tension S into this, suppose I take dl force, dl length, then S, so total upward force, this is F only on dl element, df. So, you will have df force as S into dl, but I want my force to be vertical. So, what is the net vertical force, so that I can equate with the weight of the liquid it has to raise. So, this becomes S dl. Now, you can see this angle is theta, so will be this angle theta, so cos theta. Now, if I integrate, I will get the total force as S into L. L means again 2 pi r, so 2 pi r cos theta. This is F force. Now, at equilibrium, F vertical total upward force due to surface tension must balance the weight of the liquid, that is 2 pi r s cos theta must balance the weight, that is pi r square, h is the height, so pi r square h is the volume into density. So, here pi gets cancelled and 1 r cancels. So, h is equal to 2s cos theta by rho r, this is g also, so rho r g. So, you see the force method, that is equilibrium of forces, also establishes the same Jurins formula of the capillary rise, h is equal to 2s cos theta by rho r g. So, now let us come to third method, that is virtual energy method. So, this is somewhat important method where we talk about some energy of the system also. So, this is our liquid and this is the adjacent layer, and you see the capillary has risen to a height of h dash. So, according to the virtual energy method, according to the virtual energy principle, very important point, if a system is in equilibrium, then any infinitesimal change in constraint does not increase or decrease the potential energy of the system. So, this is very important theorem. So, whenever a system is in equilibrium, it gives us a tool to know the equilibrium condition, to know the forces involved in creating that equilibrium condition. This is the equilibrium rise. That means this is in equilibrium state. The rise of liquid due to capillary forces, the adhesive forces, the surface tension forces is in equilibrium. So, now let us increase this by a small quantity h, so that the meniscus goes by it. So, let us increase the height, the capillary rise h by a small quantity dh. So, I have increased dh. So, now let us see by what factors all other quantities, all the energy sources changes. So, let us see what about the increment in energies. With an infinitesimal change in h by a small quantity dh, there is a gain in kinetic energy, the gain in the potential energy. So, number 1 point, gain in gravitational potential energy is equal to, what is the mass? The mass is rho, pi r square is the cross sectional area into dh, rho area into height and into g. So, this is the whole mass mg into again h. So, it is rho h pi r square dhg. This is the gain. So, this is point number 1. This much gain of potential energy is there. Now, you see some of the solid area, some of the solid wall area of this capillary tube is now weighted with liquid, has been immersed in liquid. So, there is a loss of area equal to, suppose I say 2 pi r into delta h or dh of the solid, there is a loss of area of this, which causes a loss of energy, of potential energy associated with it. So, there is a loss of potential. So, this is gain is positive, loss is negative. So, how much? So, 2 pi r dh, 2 pi r is the length, this and this. So, this is a curved surface area, 2 pi r dh into the surface tension of solid in contact with the gas. So, this much is area is lost. Next, something is also gained. Now, there is a gain of area equal to 2 pi r dh of the solid which is in contact with the liquid. So, this area is increased. Thus, there is a gain of potential energy, we call it surface energy, free surface energy, that the potential energy associated with it, that is 2 pi r dh into surface tension of the solid in contact with liquid. So, you see here 3 things are there, 1 gain and 2 loss. Since there is no change in the potential energy of the system, this gain must be compensated by these 2 loss. So, thus from virtual energy method, the principle, this is the sum of these 2. So, let us write this quantity, this is actually gain must be equal to the loss, that is here 2 pi r dH surface tension of solid in contact with gas. So, this is again the loss, this is the lost energy, and so it comes to be plus minus, this is again the energy gain, not loss, dH solid. So, you see this is the lost, the surface of the solid in contact with air is lost, this is lost, and what is gained? So, this is this side actually, so I have here written, so minus. So, this is gain. So, now you see, let us see, some things cancels out, let us cancel those things, dH, 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 2 pi r and here pi r. So, here by 2 will be there. So, 2, let us remain 2 here. So, we have 2r S of solid gas minus solid liquid is equal to rho H R G. So, this is R and this is R square. So, R is also not there. So, now you see H is 2 times solid liquid by rho Rg. Now, let us recall, you just recall this, our contact angle definition, that this was solid of liquid and gas in contact, this is solid with gas in contact, and this is solid in of solid and liquid in contact, this is theta. So, this term Sg minus Sl was equal to 2 surface tension of liquid and gas cos theta by rho Rg. So, which comes out to be 2s cos theta by rho Rg. So, no need of every time writing liquid in contact with gas, liquid in contact, that is S only. So, thus the virtual energy method also tells the same expression for Jurins formula, that is H capillary is 2s cos theta by rho Rg.